Hello, my name's Anthony Sanchez. My final project for Computer Science 42 Architecture and Organization. My project uses one Arduino Mega 2560, one LCD screen model number 1602A that was included with the starter kit, one 60 multicolor LED ring, two large push buttons, two slider buttons, one potentiometer, seven resistors, six LEDs, and a lot of wires. Vroom-Skeet is a game that's a physical game that's inside of a card game for drinking, where players put their elbows on a table, point their thumbs in the direction they want to send a virtual car, while at the same time saying vroom to keep the car moving in the same momentum, or skeet to send that car back to where it came from. In order to turn that physical game into an electronic game, the Arduino powers the LCD. A greeting message is displayed. Welcome. Instructions: use only the gas or brake pedals to keep the vehicle going in the right direction. Before the start of the game, I wanted to mention the two libraries I use: Adafruit NeoPixel to control the LED ring and Liquid Crystal to control the LCD display. It's really the heart of the program. The libraries do a lot of the functionality. Also at the heart of Vroom-Screech is the randomness for the program to go clockwise or counterclockwise. One of the obstacles I had to overcome was to get the random method to work, because it doesn't work unless you seed it. In this case, I seeded it to analog 0, which allows the random method to work when I call on it. After the instructions, level 1 is displayed. There are 5 levels, and each level has 5 rounds. It says ready, set, go, stay, and it will give you the objective clockwise, also showing your score. The vehicle is sent counterclockwise. The objective is to stay clockwise. So I would push the brakes to send it back the way it came. At the start of the game, two yellow LEDs are powered on. Turning those yellow lights either red to send the vehicle back or green to send the vehicle forward on both the computer and player side was one of the first challenges I had to overcome. The fix is a simple variable that's used right before the computer or program decides to go clockwise or counterclockwise. There are 4 correct decisions that a player can make when the vehicle is on their side of the ring. One of them here is if the gas pedal is pressed and the brake pedal is not pressed, the objective was to stay clockwise, but the vehicle actually vroomed clockwise. So if they do the gas pedal on those circumstances, it'll go through the code, send it back, and then the variable for the program to flash green or red when it makes a decision is stored at the end. After the first version of this game, which was entered into the Merced College Science Fair for 2021, I came back to the project and I wanted to it gave me an opportunity to revise some things. I did 2 attach interrupts. The first attach interrupt comes to this slider button. It's to pause the game, and then the second attach interrupt comes to this slider button, which is to reset the game. Whereas the gas and brake pedals are simple push buttons without interrupts. So the pause attach interrupt calls on this method that I called parking brake. It displays a message that the game is on pause. And then all that happens is a while loop that does absolutely nothing. But what it is doing is it's constantly checking to see if the pin for the park input or the pause input is pressed or unpressed, if the slider button has slid back over to the unpause state. When it does, the while loop will end. It'll display that the game has resumed, and the method will end. The second attach interrupt restarts the game. I named it the method restart engine. The first thing it does is to reset all the variables back to their original parameters. So all the rounds, levels, the speed of the traveling LED, and the counter time, because you get 9 seconds to make a decision, is reset. And then after that, it's displayed that the game has restarted, level 1, round 1. And then I did have to put a while loop to hold it here because with the slider button, it kept calling and re-entering this method and the LCD would keep flashing. So it'll hold here now with this while loop until the input is unpressed or the slider button is slid over. So after the instructions are displayed, the level is displayed. There are 5 levels and each level has 5 rounds. Then it says ready, set, go. And then it'll say stay, and then it'll show clockwise. It sent the vehicle clockwise. So when it gets to me, a countdown begins from 9 seconds. I have 9 seconds to press a pedal, either the gas pedal or the brake pedal. Since the objective is to stay clockwise and it was coming clockwise, I would press the gas pedal. My LED would turn green as well as this gas pedal here. I collect 50 points. And then it goes on to the computer's turn or the program's turn. Ready, set, go. It goes from yellow to red because it's sending the vehicle back the way it came instead of keeping with the momentum it was going. If it was keeping with the momentum it was going, that LED would have turned green. It comes back to me, the 9 seconds count down. The objective is clockwise. It came counterclockwise. So I'm going to send it back the way it came by pressing the brake button. I collect 50 points because it is correct. The computer or program uses the random method to decide which way to send it. It decides to keep that momentum going the same way, so it presses the gas. A green light is displayed. It goes clockwise to me. The objective, however, is counterclockwise. I have 9 seconds to pick a pedal. I'm going to send it back counterclockwise. I collect 50 points. As it comes back with your objective, it does also show you your current score. And to show you what's happening with the code, I have my variables declared there. I have 2 attached interrupts here for the pause and restart. I have the random seed, which allows the random method to work. I activated the LED pixel. I activated the LCD screen. So to finish the algorithm of how the game is played, the other win option is if the gas pedal is unpressed, the brake pedal is pressed. The objective was to stay clockwise, but the vehicle actually went counterclockwise. So if you press the brakes in that situation, that's one. The other one is if you press the brake pedal when the objective was to stay counterclockwise and the vehicle actually went clockwise. And then the last one is if you press the gas pedal when the objective was to stay counterclockwise and the vehicle went counterclockwise. If anything other than those 4 situations and buttons are pressed, then the game ends. And so it would say crash. All right, you've seen what happens with the algorithm when you make a correct split decision. Now I wanted to show you what happens when you don't. Here I'm running out of time. So there's a light sequence for crashing. There's also a message on the screen that you crashed. Here I'm just going to make the wrong decision. It wants me to go back. I'm going to press the gas to go forward. It says you crashed, a light sequence. And finally, I just wanted to show you that there is an algorithm to make the game harder. The 5th level is the last level. And so the speed has increased. The seconds to make a decision is only 3 seconds, 3, 2, 1. I pressed the gas, which was the wrong decision. Apparently, vehicle sent clockwise. Objective is to stay clockwise, press the gas to keep it going. The computer sent it back.